Today we will be learning how to calculate the concentration of hydrogen ions, the concentration of hydroxide ions, or the pH and pOH through given concentrations. So today's target is to calculate those concentrations, or pOH, of different acidic and basic solutions. So one of the things that we really do have to remember or be able to do prior to this is identify where what looks like an acid versus a base. And of course, the acid strengths would be which is your strong or your weak acids. Also, we should be able to identify whether an acid is monoprotic, diprotic, or triprotic, monobasic, dibasic, or tribasic. Let's take our calculators out right now, everyone. Pull out your calculator, and then we're going to locate what is called the log function as well as the inverse log function on your calculators. So let's go ahead and do that first. Let's pull our calculators out. And on your calculator, there is a function called the log function. It's this button right here. To access the inverse log is to press the second button and then press this button. And so the inverse log is really 10 to some x power, as you see closely here. So make sure you can locate your log function as well as how to access your inverse log. So let's go ahead and do our, let's look at our concept map. So this is a map of the four corners represents either hydrogen ion concentration or hydronium ion concentration, which is, remember, all it is a hydrogen ion with water attached. The hydrogen ion has attached to the oxygen in the water molecule, which makes hydronium. And here you have pH on this corner, pOH on this corner, and the OH concentration on the top right-hand corner. Now, as you maneuver through between each of these, whether you want to calculate the H plus from the OH minus concentration, you need to use these equations appropriate and just substitute it in and solve for what you need to solve for. Likewise, if you're going downward, where you're going from the hydronium or hydrogen ion concentration to the pH, you will need to take the negative log of that. And that's what P represents. P really means negative log of something. It's a function. And then if you want to go the opposite direction, you have to do what is called the inverse log. And so that's why it's 10 to the negative pH. Likewise, over here, if you want to go from the OH concentration, minus concentration, to pOH, you're going downward. So that means you're using pOH equals negative log of the OH concentration. If you're going the reverse way, you're going to have to take the inverse log, so 10 to the negative pOH. So this is a really great map to maneuver through your calculations. So let's go ahead and start with our first example problem. Best to really just start off by doing problems to help us to understand this. So here's our first example. Our first example is where we're taking the H plus concentration and we're calculating the pH. Now always have your map accessible, so always make sure your orange sheet and half sheet map is there for you. So in other words, we're trying to go from H plus concentration to pH, which means we're going to use this equation right here, which is pH equals negative log of H plus concentration. So I'm going to set up by writing that equation out. pH equals negative log of the H plus concentration. So let's take a read of what we're looking at here. It says, what is the pH of a 0.300 molar solution of a weak monoprotic acid? Now, the minute I see the word weak acid, mono meaning one hydrogen ion that it will release, but weak acid means it only ionizes so much, and usually it's less than 10%. So let's think about this for a second. If 100% of this amount ionized, that means 100% of it, which means 0.3 molar of it is going to be hydrogen ions. But only 10% of this amount will ionize. So that means you take 10% which is 0.10, this is 10% as a decimal, and you times it by your concentration, and you will end up with the 0.0300 molar H plus ions. So you're taking 10% of the concentration of your acid, which is 0.3. And so this is how much hydrogen ions there are in the solution, because only 10% of that amount of 0.3 will ionize. So once again, just make sure you do your math. 0.1 times 0.3 will give you 0.03. Notice 0.03. So now you have your H plus concentration. So all you do is take pH equals negative log of that value. And so you punch this number into your calculator. So I'm going to clear it to make it as though we're starting anew. Here's my negative button. I press the log, 0.0300 in parentheses. And that then gives me my answer, which is pH equals 1.523. So here's my answer, and it checks off with the answer that I have up there. Now, class, the sig fig rules for pH or log functions is actually different from our typical sig fig rules, but you'll never be held accountable to it. So the way the sig fig rule works is if you start off with 3 sig figs, like you see in this number right here, 1, 2, 3, what you do for your sig fig for your final answer will be add 1 more sig fig to that. So you'll have 4 sig figs, 1, 2, 3, 4. You won't be held to the sig fig rules for that, okay? So let's look at the next problem. The next problem says you're going from pH to H+. So let's see how that works. So it says, what is the hydronium? Now, hydronium is H3O+, ion concentration if the pH of a solution is 1.10. So once again, have your map accessible. You're given the pH, and you want to go to the hydronium ion concentration right here. So the equation you're going to use is this equation right here, which is H3O+ is equal to, 10 to the negative pH. So I'm going to go ahead and plug it into the equation. So H3O+ equals 10 to the negative pH, which is 1.10. So this is the pH right here. So to access my inverse log button, I press second and then the log function. And notice 10 is raised to some power, and I want to raise it to the negative pH, which is negative 1.10. If you want to add that 0, doesn't matter. The calculator doesn't know how to do sig figs. So the answer in the end is 0.079 molarity. So these brackets really represents concentration in molarity. Molarity, so brackets represents molarity concentration. Okay? Let's go to example number 3. In example number 3, we're looking at a polyprotic or polybasic situation. So in this case, you're looking at the acid, and you'll notice that this acid is diprotic. And how you know it's diprotic is you see 2 protons. And it's a strong acid. So not only is it diprotic, but it's also a strong acid, so 100% of it will ionize in the end. So if I have this amount of this whole acid, and it's going to ionize into twice as much hydrogen ions, and all of it will ionize, that means the concentration of hydrogen ions that I have in my solution is going to be 0.02 molar. And that's because twice this amount is 0.02. Now, to calculate the pH, is to say negative log of the H plus concentration, which is 0.02. So I'm going to do it step by step so you can see my substitution. And so once again, take out that calculator, clear it up, negative log of 0.02 in parentheses will give you 1.698, which is 1.7 in the end. So your pH is 1.7. So you do always have to look at what whether your substance is an acid or base, and whether it's strong or weak, and then whether it's polyprotic or polybasic. Let's take a look at number 4. It says, what is the hydroxide ion when 0.0 or 0.203 molar of HNO3? Notice this is an acid. Notice, is it strong or weak? It's a strong acid. So strong acid we're looking at. So we're looking for the hydroxide ion concentration. We have the hydrogen ion concentration. So the hydrogen ion concentration is whatever this amount is. We want the hydroxide ion concentration. Once again, I'm looking at the map. I have my hydrogen ion concentration. I want my hydroxide. Notice the equation we're going to be using is this, where you multiply those two concentrations and they will equal Kw, which is 1 times 10 to the negative 14. So substituting that in, hydroxide ion concentration is what I'm looking for. The hydrogen ion concentration is 0.203. That will multiply to equal Kw, which is 1 times 10 to the negative 14. So it looks like I'm going to have to divide both sides by 0.203. And so now I have to use my calculator to do that step right there. So in my calculator, I'm taking 1e to the negative 14 divided by 0.203. And my answer is 4.92, or really 93 times 10 to the negative 14. So really there's a slight little error here. So it's 4.93 times 10 to the negative 14 molarity. And that's the hydroxide ion concentration. Okay. So now we go to number 5, example number 5. This is our last example. In example number 5, you're going and doing 3 steps. You're given a base, a strong base. So I know that this is a base because it's got the hydroxide ion, and it's polyprotic. Notice there's a it's dibasic. So it's polybasic. So it's a strong base and it's dibasic. So really, this will tell me how much concentration of hydroxide ions I have. And it looks like I'm going to have twice that amount, and all of it ionizes. So I'm going to know that however much I have, all of it will ionize into twice the amount of hydroxide ions. So this is how many hydroxide ions I have. And now I want to calculate the pH. So according to my map, once again, my map will tell me I have my concentration of my hydroxide ions, but I want to get to this corner. I have 2 routes. I either go through this to get to the pH, or I go downward and go across this way. I actually think this way is going to be easier, just calculation-wise, because all you're going to do is you're going to take the pOH, which is negative log of the OH concentration, and then you're going to subtract 14 to get the pH in the end. So I'm going to go down and then go to the left, okay? So going downward, I'm going to calculate pOH first. To calculate pOH is to take the negative log of the OH concentration, which I have here. So when I do that, my pOH ends up being 0.699. And so now I take my equation that I'm using is pH plus pOH equals 14. So I'm going to substitute 0.9 or 0.699 into pOH plus pH equals 14. So essentially I'm going to have to subtract 0.699 from 14. So I leave this number in my calculator and I subtract whatever answer I have, which ends up being pH equals 13.3 in the end. So there goes my answer. I hope this video helps. I'm going to send it out as a remind text, the link out as a remind text as well. Good luck. Go ahead and do your set problems.